Listo, estamos en vivo.
Ok,
Hola, hola.
listo.
Hola a todos.
¿Qué tal?
Feliz noche.
Feliz
Buenas
noche a
noches,
todos.
bienvenidos todos a este nuevo meetup de la comunidad de apache.spark.bogota. Los saludamos sus anfitriones, Juan David Bolaños, Miguel Díaz y quien les habla, David Arevalo. Bueno, no, estamos muy contentos, creo que hoy es un día bien especial para la comunidad. Hoy tenemos un súper invitado. Hoy va a estar con nosotros Jules Damji. Él es Senior Developer Advocate en Databricks, contributor del proyecto MLflow y pues coautor del libro que hemos entregado en la comunidad, el libro de Learning Spark. Bueno, vamos a hacer una introducción rápida de qué es nuestra comunidad, ¿no? Para aquellos nuevos miembros a la comunidad, súper bienvenidos. Les recordamos, estos son nuestros canales donde siempre nos estamos comunicando, estamos anunciando meetups, donde vamos a mover nuestros concursos. Recuerden que en cada meetup estamos teniendo un concurso gracias a los patrocinadores. Tenemos nuestro canal en Slack donde nos estamos comunicando, donde algunas personas dejan sus dudas, otros solucionan y pues vamos construyendo el conocimiento, que es lo que más nos mueve. Están quedando grabadas nuestras sesiones en Twitter, nos estamos también comunicando, el correo, el meetup, y bueno, ya saben, todas las charlas son súper bienvenidas, no importa si son muy senior, muy junior, por favor, todas son bienvenidas. Lo importante es que compartamos el conocimiento dentro de la comunidad. Bueno, ¿qué hacemos? Hemos venido desde el 2019, desde el 7 de marzo, me he dado cuenta hoy, desde el 2019, empezamos a hacer una serie de meetups buscando promover la implementación del framework de Apache Spark dentro de la comunidad en Bogotá. Inicialmente, dada la contingencia de esta pandemia, pues nos permitió abrir ya a Latinoamérica y poder tener participantes desde Ecuador, Perú, Medellín, de todo lado estamos teniendo speakers y pues bueno, participantes también, así que a todo el mundo, bienvenidos. Bueno, ¿qué queremos ser? Pues ese grupo referente de Apache Spark en América Latina, reunir los mejores talentos e invitarlos a enseñar. Sabemos que hay mucha gente que tiene mucho conocimiento, que está por allí, por todo el mundo y pues bueno, este es el punto de encuentro para todos. Desarrollar talento, es algo que nos hemos propuesto sus anfitriones, a organizar los talleres y pues bueno, que todos den una charla de esto que están aprendiendo. Esta es una foto de uno de nuestros primeros meetups que tuvimos. Esto fue en el 2019. ¿Esto fue dónde? ¿Dónde fue? Bien. Bueno, fue en ese momento el nombre dónde fue.
Perdón, es que estoy acá escuchando
Perfecto, en Neveris, listo. Y tuvimos también nuestro primer workshop en el 2019. Esto fue en PU. Pues, saludos a la gente de PU. Bueno, como es habitual, todos los días estamos teniendo un concurso. En los últimos concursos hemos entregado unas copias de nuestro speaker del día de hoy. Y pues para el día de hoy vamos a entregar 2 copias que en esta oportunidad Jules Damji nos está obsequiando a la comunidad. ¿Sí? Y esas 2 copias las vamos a entregar a ustedes. ¿Qué hay que hacer? El concurso es súper sencillo. Es participar en Twitter y en LinkedIn etiquetando las redes de la comunidad. En Twitter estamos como @BogotaSpark. En LinkedIn estamos como el hashtag apache_spark_bogota y también tenemos un grupo que es Apache Spark Bogotá. Allí el Bogotá es con tilde. Bueno, ¿qué hay que hacer? Participar en las redes sociales, hablar acerca de la charla de hoy. Si tienen preguntas, plantéenlas por allí. Si tomen fotos, activemos estas redes sociales. Y responder a una de las preguntas que Jules nos va a hacer durante la charla. Jules tiene una pregunta y durante la charla nos la va a plantear para que podamos responder a esta pregunta. Bueno, ¿cuáles son los criterios de evaluación? Entonces vamos a entregar un libro para quien dé la respuesta más creativa a la pregunta que nos va a hacer Jules. Se vale cualquier tipo de respuesta, ¿sí? Y vamos a entregar otro libro para quien logre más reacciones, y aquí importante, reacciones positivas en cualquiera de las redes sociales. Bien puede ser en Twitter o bien puede ser en LinkedIn. ¿Hasta cuándo tienen plazo para participar del concurso? Bueno, hasta el 27 de septiembre del 2020. Este es el premio que vamos a entregar y es uno de los libros de Jules Damji, que es Learning Spark, y es de O'Reilly. Bueno, vamos a ver si ya tenemos a Jules dentro de nuestra llamada. Creo que aún no se ha unido. No. Listo, mientras vamos a
Que hemos hablado, José.
Vamos a darle. ¿Cómo?
Estoy esperando los aplausos del público para entrar.
Sí.
Ojalá no nos deje metidos.
Pues
¿no?
sí, muy bien. No, claro que no.
Pero...
Bueno, mientras que Jules se va uniendo, tenemos pues la invitación a que quienes quieran unir al Meet, a la sesión de Meet, pues son bienvenidos. ¿Cómo lo vamos a hacer? Lo vamos a hacer, deberán escribir por interno, por el grupo de Slack, escribir por interno, hey, quiero entrar al Meet, eventualmente para hablar o para enviarle alguna pregunta a Jules, y pues allí dejar, y allí le vamos a hacer llegar el link para que puedan ingresar.
O sea,
Importante, por favor.
apache.spark.bogota y
Sí.
les mandamos el link.
Perfecto. Importante no compartir este link en ningún lado. Lo vamos a mantener cerrado solamente dentro de la comunidad. Entonces, por favor, no lo vayan a compartir en Twitter, en ninguna de las redes sociales, porque pues queremos mantenerlo cerrado, ¿vale? Bueno, mientras tanto, Miguel tiene una sorpresa. Así que, Miguel, cuéntanos de la sorpresa del día de hoy.
Bueno. Entonces, imagínense que justo hoy recibí un paquete de Amazon. Entonces yo creo saber qué es, pero vamos a ver y vamos a hacer la destapada del unboxing ya mismo. Entonces, one moment. Con las tijeras. Vamos a ver. Si no es, pues bueno. No. Es fake. Pero si es, yo creo que sí. Mírenlo, acá está.
Sí, solo pides libros por Amazon, ¿cierto?
Vamos a ver.
Ojalá.
Sí. Si no les muestro, ya saben qué era. Sí. Pues bueno, vamos a ver qué tal esta vaina. ¿Qué fue lo que nos mandaron a la comunidad? Bueno, señores y señores, efectivamente llegaron los 2 libros patrocinados por Rappi. Así que...
Súper. Nosotros tenemos ganadores para esos, ¿ya? ¿Cierto?
Ya están. Ya justamente...
Pero el curso ya finalizó, eso es del mitad pasado, ¿no?
Tal cual. Uno es para Daniel Amariles, así que pronto irá...
Felicitaciones.
Rumbo a la casa de Daniel. Aquí voy a decir rumbo a Cali, ¿sí? Entonces, pues Daniel, espéralo. Está pendiente justo para vos, ve. Y el otro...
Ese es el de Jules, ¿cierto?
Sí, tal cual, es el de Jules.
Sí.
Ahí está.
Súper.
Es el de Jules. Y el otro es el de Julián Bolaños. Vale, entonces creo que el de Julián...
Pegó en el palo, no era para mí de casualidad.
Ese nombre está sospechoso. ¿Y por la en el norte?
Sí, es
Julián, pegó en el palo.
No, sí es Julián Buitrago. Julián Buitrago. Sí, yo creo que
Me emocioné.
lo tienes hoy mismo y Daniel lo tendrás, no sé, mañana lo llevo a hacer entrega y te lo envío. Pero Julián sí creo que lo va a tener hoy mismo. Así que escríbeme y queda pendiente ahí de tu libro.
Excelente, felicitaciones a los ganadores. Y de nuevo, muchas gracias por participar. A la final nos nutrimos de su participación, bien sea como espectadores, bien sea como speakers. Todas son bienvenidas, todas son igual de valiosas. Entonces, anímense, anímense en los concursos, esos no le hacen daño a nadie, no tienen que hablar en público. Y si quieren hacer una charla, pues con más veras, porque al final de eso es nuestra savia vital. Esas charlas las necesitamos para cumplir nuestros objetivos ya los que mencionó José antes, ¿no? Queremos formar talento y queremos crear comunidad en Colombia para que sea referente de Latinoamérica.
Genial. Entonces, sí, bueno, y la seguridad ante todo, ya me eché alcohol. Yo tengo harto cuidado con los libros, así que estén tranquilos, estén tranquilos. Bueno, entonces, todavía nadie escribe por el canal de Slack para entrar. Y bueno, creo que todos estamos pendientes ahí aplaudiendo a ver si entra Jules. Mientras tanto...
¿Tenemos problemas técnicos, José?
No, me dice que ya está por ingresar. Entonces, vamos a ver. Me dice que ya está haciendo el join. No sé, ahí a ti te llega la alerta, ¿cierto, Miguel?
Mira, ya. Mira, Jules escribió. I have joined the Google Hangouts. Acá escribió pero creo que se metió a otro.
Sí, no creo.
Pues ahí dice que ¿por qué?
Ajá.
Por YouTube acabo de escribir.
Y si confirmamos, José, si confirmamos el enlace con Jules, tú que tienes contacto.
No. Sí, ya.
Bueno, por acá.
No, creo que... Pues déjame, le acabo de compartir. Ok, bueno. Le acabo de enviar nuevamente.
Por acá ya va la primera participante que nos escribió por Slack y le acabé también mandar el link para que se una a la llamada. Sabrina Pesetti. Voy a revisar acá algo.
Ok. Creo que tal vez parece que está en otro link Juice. Ya le vuelvo a confirmar.
Veis, si lo mando por YouTube ya. Igual en este momento hay 35 personas. Hijo de madres, ¿no? Lo vamos a andar por ahí.
Dios mío.
No, pero yo creo que es mejor contactarlo. Sí, porque puede nos pase lo de la vez pasada, es mejor pues tenerlo cerrado por ahora. Quedé traumado, todavía tengo pesadillas.
Unas pesadillas con eso. Bueno, mira, ahí está Sabrina Pesetti que nos escribió ahorita. Pues bienvenida, Sabina. Jules, ahora sí. Hola, Sabina. Hi, Jules. Welcome.
Hello, Jules. Great to see you here.
Finally.
Thank you so much for joining us.
Can you hear me? Can you guys hear me?
Yes.
Yeah.
We can hear you fine.
Because I knew when you were flashing those books, I know you were talking shit about me.
No. And we were saying this is a very special meetup because today we have a very special guest, and coincidentally, the books that we aim to deliver as gifts in previous events were those books that you created. We truly believe that should be our reference book going forward. So we are more than happy to have you today, Jules, and nice to meet you. I'm pretty glad to have you here with the community. I think this is great for all of us, and well, looking forward to getting to having more of these events and having you here in the Bogota Apache Spark meetup more frequently. So I don't want to take out the microphone from you. So go ahead.
You're on mute. Like this is
you're mute, Jules.
Unmute myself, and then let me see if I can share my screen.
Cool. And here you missed the unboxing, yeah?
Oh, thank you.
Yes.
Thank you. You received it. But you have to answer my question in order to win the book, and they'll come at the end.
But yeah. Just to clarify, these are from prior events.
Okay. These are from Cloudera.
Yes.
Other events. Yeah.
Okay. All
That's right.
All right.
Yeah.
So Jose, did you get the book that I sent you?
Not yet.
Oh, you did. Okay. All right. Brilliant. One book is for you, so it's up to you whether you want to raffle that, because I've signed it. And the other book will go to someone who actually answers the question at the end. So let me share my screen over here. You can see my screen, hopefully.
Yeah.
Not yet.
Can you see me now?
Not yet. I cannot see it.
I can see your screen. Yeah, your presentation. Yeah.
You can see it? You can see it?
Yes.
Okay. Let me know. Give me the green light when you're ready for me to present, to start.
Whenever you want.
Oh, okay, brilliant. Then
Yes.
we should waste no time.
That's right.
Because time is money and Spark is lightning fast, so we don't want to waste our time. Well, buenas noches, amigos de Bogota Spark. Thank you very much to all of you for welcoming me here. I'm delighted to be here. As you know, that this year, this decade, is the 10th anniversary of Spark. And yes, 10 years has been a long time, and Spark has gone through a lot of changes in the last 3 years, 3 major releases, over about 600 different Apache Spark groups all around the world. We're close to about 500,000 subscribers and meetup members. And thanks a lot for Bogota Spark to keep the Spark going in the Latin America part of the world. So I'm really delighted to hear. And then special greetings from the original creator of Apache Spark. Happy birthday to 10th year. And so this is actually delighted to be part of the 10-year anniversary of Spark. A lot of things that actually happened in Spark. Now, a little bit about myself. Those of you who actually have read my bio and those of you who have not, I'm a developer advocate here at Databricks. And prior to that, I was a software engineer at some of the companies in the Valley. My little white beard over here shows that I'm a geezer, old guy. I have worked at various companies in various capacities over the years, and most recently have had the great opportunity to share my knowledge with people in the community. So I really enjoy this work because I get to learn, I get to know, I get to share with you people. And just to give you an idea of the company I work for, Databricks is the company I've been for about close to 5 years. And we provide sort of a unified platform that allows data scientists like you, data engineers and business analysts more recently to solve real tough data problems. Because as you can see, that we have entered the dawn of data. We are at the zeitgeist of data, and data is there for us. And how do you deal with large amounts of data? How do you analyze it? How do you grapple that? So our mission has been right from the start to make big data simple and make sure we provide people like you in the community with the platform that allows you to do that. We are a global company, we have lots of customers. And for those of you who don't know, we were the original creators of the Apache Spark and some of the open source ecosystem projects that have emerged as a result of the innovations which were built on top of Spark. And you're going to hear about Delta Lake today. I'm wearing a t-shirt called Delta Lake, as you can see. And so this is an important year for us, an important year in the sense that Spark has reached the maturity of 10 years. And 3.0 was a phenomenal release from 1.x to 2.x to 3.x. And there were probably more features in this particular release than I can actually think of since I've been working with Spark from very early days. And these are just the highlight of it. And there's no way I can actually give you overview and in-depth discussion about all of these particular features. But what I'll attempt to do today is to give you an overview. Think of it as a 1 hour trailer of a 5 hour movie in a short amount of time. So these are some of the highlighted features that have emerged because of Apache Spark. And if you look at it at a very high level, we addressed about close to 3,400 in JIRAs in Spark 3.0. And the majority of the work actually went in performance of Spark SQL and the Spark core. That's where most of the JIRAs actually went to. In addition to that, we have sort of constantly been working with the community and at Databricks to make sure that the documentation and the tests that we actually provide are top-notch. In other words, you can do something, you can discover something from the documentation right away. So there's been a lot of effort in that particular sector of the feature. And you can read this particular blog that I have on the right-hand side. There's a link to it. I'm going to share the slides on LinkedIn, and I'll send a link to Jose, and you can share with the Badawas community to actually get that. So that's actually at a very high level. And so since I can't talk about everything, what I'm going to do is what I decided to do for this particular meetup is to sort of consolidate and put them into appropriate categories that actually matter to people in the community. So first, we're going to start with talking about performance. What are some of the performance underlying Spark Core and Spark SQL that actually have gone into this particular release? What is it about those features that has made Spark a lot faster, a lot cheaper, a little more flexible for developers to actually use it? And then we're going to move on the same theme about how the usability and some of the documentation and some of the added features that had made Spark easier to use in terms of the APIs and in terms of other format statements that we actually have introduced, and documentation as well. And then obviously, whenever you actually have a major release, people are always apprehensive about, well, what are the compatibility considerations that I have to consider? If I'm running 2.x and I want to figure out, should I actually change? And if I change, what's going to break? Or what are some of the compatibility considerations I should consider? Or what are some of the behavioral changes that I should be aware of? And so we have decided to share with you some of those concerns that you might actually have whenever you're going from one release to the other one. And last but not least, and I think is an important part, is how has Spark sort of evolved over the past 10 years, and what it has enabled the larger Spark ecosystem to create innovations on top of that. And in particular, I'm going to lean on and talk about the Delta Lake, which was introduced last year, the project Hydrogen, which is actually an ongoing effort, and then most recently this year, the project Zen, which was inspired by the Python community when they wrote the document or the white paper, a book called the Zen of Python. So that's how we're actually going to structure our talk today in those 5 big categories, and I'll touch on some of the important nuggets because there's so much of it. There's no way I can cover that in 60 minutes or so. So let's jump right into performance. And in performance, I'm going to talk about, in particular, about adaptive area execution, which is has been improved and it's new, the dynamic partition pruning, and what are some of the join hints that you can provide. And as usual, I like to include an asset that you can actually further down if you're suffering from insomnia and you can't go to sleep. There's a blog associated with it. You can actually read that and it'll be a good cure to your insomnia. So there's a lot of notebooks in there that you can actually bring it up in the community edition, and you can actually see what does it actually mean to have an adaptive query execution before you enable it and after you enable it. So you have a good chance to actually look at that. So let's get straight into what is adaptive execution. Now, the handsome gentleman you actually see on the right-hand side is Michael Ambrose. And Michael Ambrose was one of the first early creators of Spark SQL and the initial Catalyst optimizer. He also brought us data sets and data frames in Spark SQL and structured streaming. So he has been with Databricks and with Spark from the early days in Berkeley. So in 1.x, the default optimizer was a rule-based optimizer. So whenever you actually had a Spark query, it went through the rule-based optimizer, and the rule optimizer was very rigid. You know, if I see a filter, if I see a join, if I see a select or project, I'm going to organize my operational tree in a rule-based manner. And that's a very common technology used by optimizers, say in SQL or in any language that uses AST trees, right? So the first optimizer was 1.x. In 2.x, we sort of extended that by adding what we call a cost-based optimizer. And what the cost-based optimizer did was, after your query had actually gone through all the initial phases of the journey in creating the logical plan, we associated the cost associated with the physical plan in order to execute that. And that was actually 2.x, which was not bad because it was actually based on very recent technologies in compiler theory using tungsten and using code generation. So it was quite fast. And that was one of the huge speed ups gain we actually saw from Spark.1.x and 2.x. And all the data frames and data sets and SQL APIs that we introduced in Spark 2.x was based on this particular new optimizer that included Project Tungsten as a way to generate code. All that actually changed when we introduced Spark 3.0. And what Spark 3.0 did was that it introduced a new component called runtime. And what it does is that in addition to the cost per optimizer, what about if I can actually get runtime statistics after I've created my physical plan for the RDD and I realize that my shuffle writes and my filter after I've done the shuffle is a lot smaller? What is it I can do to feed back to the original logical plan and rewrite the plan in a way to take care of the statistics that I actually found? And that has been sort of the genesis of this Spark 3.0 called adaptive query execution. Now, for you to understand what adaptive query execution is, it's important to get the historical context, or those who are not familiar with Spark 2.x, how it actually worked. Now, this is a typical journey that all your data frames and all your Spark SQL will actually go under 2.x. Your query will be sort of read by the unresolved logical plan, which consults the underlying catalog to figure out what are the columns that you're actually looking at, what are the table names you're looking at, all the metadata associated from the catalog, in this particular case, Hive Metastore, will be transferred over, and then logical plan is actually created. And the logical plan then gets optimized by rearranging your Spark operators. If you're doing filter, if you're doing join, it will rearrange and group them together so that you can actually execute in one particular stage, and then the stage gets broken down into tasks, and the task can be executed in parallel. And then once that's actually done, the physical plan is actually created for the final logical optimized plan. And the physical plan associates certain weights based on certain statistics about the size of the file, the partitions, the metadata, and the CPU and all that. And then finally, the last part is that we'll select one physical plan and we'll give it to the code generation, which is the last bit where the tungsten host code generation comes in. And this is where the Spark really optimizer works as a compiler. And this is a great blog that was actually written when the time we released this optimized version in 2.x, where you could actually join 1 billion rows per second using this particular new technology. So, you guys are probably asking, well, what's wrong with this? I mean, you got huge performance gains, so what's wrong with it? I think the idea was that what if at runtime data, when I actually have my RDD as a runtime, can I do something over here that I find out that I didn't know around here, that I can feed it back to the logical plan, and I rewrite the plan so that this now becomes more efficient? And the way the adaptive execution plan did was exactly this thing. What it did was, at the time when it was executing these RDDs, it sent back the data to the logical plan to say, hey, listen, I've discovered something when I did the shuffle and I did the filter after I did the shuffle to see that you could probably switch your join strategies, right, on the fly. And so it will actually rewrite the plan to change the join strategies to something more efficient if it finds that necessary. The other thing it could actually do was that if it detects that there were too many shuffle partitions that were actually created, and there's no need to have all the small partitions, because now you're going to create a lot of IO activity, because now you have all the small partitions and each task is allocated to the core. So you're doing a lot of churning there. I'm going to coalesce the partition. I'm going to bring it down to a smaller version and a larger size of the partition, and then assign it to all the cores available for me so I can execute that in parallel. So that's the second thing actually it does. And the final thing it actually does is that if it detects a data skew, it's going to somehow address that dynamically. So that's actually done in this final phase, and that's why the adaptive execution comes in. So let's look at more in detail what actually happens, or what are some of the performance pitfalls that AQE actually addresses that we couldn't do it in 2.x. One was that it allows you to choose and remedy the right strategy to use the join. Now, in 2.x, you had the manual control of saying, I'm going to give you a hash, do a hash, broadcast hash join, and I'm going to increase the threshold size of my hash broadcast join, which is normally 10 megabytes, to something larger, or I'm going to give you explicitly use a broadcast hint to do broadcast joins rather than sort merge joins. And we'll get into this, what those are momentarily. But that actually becomes hard to tune because over time, your workload is going to change. If you're doing structured streaming, if you're doing batch ETL, structured streaming will increase your particular load and will create too many partitions. So you have to go and figure out, well, how do I actually adjust my threshold so it always does a broadcast join? And over time, it becomes a bit cumbersome because you have to figure out, you have to remember what should be the size of my broadcast hash join. And it can result into overuse of memory and can result into OM. So how does AQE work? So what you see over here in the picture is that you have a query on your left-hand side that Apache 2.x optimizer realized that I'm doing two joins on the left-hand side and the right-hand side. And when I actually went through the shuffled writes, I created for my right child, I saw that the size of my file was 15 megabyte, right? Which is way above your threshold for a broadcast join. The threshold for broadcast join is 10 megabytes by default. And so as it progresses, when it's actually about to read the shuffle that is actually written to do the filter to send it up to the sort, it detects dynamically to say, hey, listen, even though at first I created a short merge join and I realized that the right side of the join file was a lot smaller after I've done the shuffle reads and filtering to feed it up to my sort to do the sort, the actual size of the file was actually 8 megabytes, which is way under the 10 megabyte file for the threshold. So what I'm going to do is I'm going to tell the logical plan to rearrange the sort merge join from sort merge join to broadcast hash join. And at this point now, it's going to do a broadcast hash join, which will tell that particular shuffle file and broadcast across all the executors to do a rather quicker join. And this is far, far more efficient because now you're saving yourself from doing the sort merge join. You don't have to worry about figuring out what are my threshold sizes. You don't have to give the Spark hints to say use broadcast join. It will dynamically figure out that I'm going to have to do a broadcast join. And that's a huge, huge gain in terms of performance and in terms of the flexibility of the Spark. Even though it gives you the control to say, increase my threshold, here's the hint that I'm giving you, but do it dynamically if you see that particular fit. So you don't have to be worried about in the driver's seat trying to figure out what's going on. So that's number one, adaptive execution that actually addresses the performance pitfall that in 2.x we couldn't do it. The second performance pitfall is the number of shuffle partitions. Now, there is this magic number called spark.sql, the shuffle partitions, right? This is the number that we normally write initially when there is an exchange happening or when doing a group by, there is a stage boundary where the exchange happens and we write the shuffle file to the disk. By default, well, in 1.x, it was only 8. Right? And then we defaulted to the default parallelism, which is we would dynamically figure out how many cores do you actually have on your executor, and we'll default that to that many so we can actually have maximum parallelism. And then over time, people were using lots and lots of loads and large loads, so we increased it to 200. Now, the problem is that you have to somehow, at runtime, depending on what your workload is, to figure out what's that magic number, right? Should I stay with 200? If I keep the number too small, for example, maybe 10 or 15, then I have a potential to have my partitions be very large, and I'm going to be, doing a lot of disk spilling, and that's going to affect my throughput. If I keep the number too large, let's say 500, and if I have a small workload, then I'm going to have too many partitions. And what you're going to have is now your scheduler is tasking and shuffling all these different partitions one at a time when the file itself is too small. So all that becomes over time very hard to tune and hard to maintain. And because this is a system-wide configuration, when you change it, you got to restart the cluster and make sure the text actually effect. So that's actually cumbersome. So what the adaptive query execution does, it says, I don't care what the shuffle partitions are. Keep what the default is. Let's say your default is 200, or you decided to increase it or decrease it to X to accommodate the shifting data size in your ETL or batch jobs during execution. Sometimes at nighttime, you're running Spark. During the daytime, you're doing a lot of streaming jobs. At nighttime, you're doing ETL. And so you don't want to actually change it all the time. You keep it what the default is. And let Spark figure out what's the best optimal number that it will create that. So on the left-hand side, you actually have seen that it executed your query, did a scan, it did the filter, and when it did the filter, you wrote to your disk. And as it progresses in the query, it realizes that the 50 partitions that I actually have created, even though you told me to create 200, but I created 50 because I could fit all the data they actually have in 50 partitions, I realized that as I go further down before I send it to the sort, I can coalesce that to a smaller number so that the sort now doesn't have to get 50 partitions, but it gets a smaller number of partitions. So it dynamically coalesces that. And you don't have to worry about manually trying to figure out what that magical number is. So the second function, obviously, is that if I have a large number of partitions that I've created in a query, and my default number is 200, and I've created, let's say, 200 partitions. As I go further down the query, before I send it up to my next stage, I realize dynamically that, hey, I can coalesce those, right? So you'll go in and coalesce those partitions. So that way you have less number of partitions now for the executor to actually run, and therefore you actually have an effective parallelism. So that's number two. Number three is data skew. Now, anybody dealt with data skews while running Spark jobs? You probably have heard about data skews. And data skews are really the bane of the pain for data engineers when they're actually building large data pipelines. What happens is that you have a data skew where your partition is actually skewed. You will have some smaller partitions and you will have one large partition that's taking inordinate amount of time to finish. So when you go to Spark UI and you look at your Spark job and you look at the task, you will see that all the other tasks with the smaller partitions are finished, but they are now waiting. Your Spark job is still running. It's waiting on this big, large partition, right? Because it's got a data skew. It's a large partition compared to the other one. And it's taking a long time because it doesn't fit in memory, so it's going to read chunks of it. So you're going to have a lot of I/O thrashing going on. And that can, be a low use of utilization. Now, there are various ways that people and data engineers actually fix data skew. One was to rewrite the query in a way that you split up the partitions. The other one is salting. Salting is another strategy where you add some prefix so your key now hashes evenly, so you get a nice even partition. But that all has to be done manually, and it's extra work for you to write salting. So why not have AQE take care of it? And the way it does that is that, let's imagine in the adaptive query version, let's see the table on your left-hand side. You do a map and a group by operation. And when you do a map group by operation, what you see is that this particular map with keys starting with A after you've done the shuffle writes all into this particular partition. The other ones actually are much smaller, right? So what happens is that you actually effectively have a data skew for task one. The task one and task two and task three will get finished, but task 0 is waiting for a long time because it is now dealing with a larger partition. And this is a symptom of data skew. And you'll have to wait till that task finishes before you can actually do a join with table B. So there's skew over here and there's no skew over here. So what does adaptive execution do? What it does dynamically, it says, when I do the shuffle, when I write the shuffle, when I do a group by, and I look at the data of that particular partition, A0, I'll see that that's a huge partition. And what I'm going to do is I'm going to split them up into smaller partitions so that I can maximize the parallelism. So A0 now gets split into A01 and A01, and then A1, A2, and 3. So now you actually have all these partitions which are about equal size, and now you have maximum parallelism. So your join will be actually executed much, much faster, because now you actually have maximum parallelism. And that's what actually has done dynamically. And this is huge, huge, huge win for data engineers who are building data pipelines, who are doing ETLs, and then end up with data skews, and then they have to either kill the job or try to rewrite the hash keys with salting, so you get evenly hashed partitions down the stream. And so this is actually a huge, huge important feature that has made Spark 3.0 far more performant than 2.x, because of the fact that it can adapt itself while executing during runtime. And the way you actually enable AQE is that AQE by default is not enabled. You have to enable it by setting this particular parameter to true. And the reason we have done that is because this AQE is still experimental, even though we have done a huge, huge number of improvements from the community and also from Databricks to make sure that this is more stable. And we have just normally, as our practice is, whenever we introduce a new large feature, we normally make it experimental. And then in the subsequent release, after you've got the feedback from the community and after you've addressed some of the JIRAs associated with that particular feature, we normally then timestamp this as production ready. So right now you have to enable it to true. And because of that, what you have is this other property in the configuration file called coalesce partition enabled. And that is set by true, but it only happens if the global setting is set to true. So this particular setting over here works with this setting over here. In conjunction with this setting, you got two more settings that you actually have to set, or you can leave it to default. One is minimum partition number. What this does, it instructs parse to say, okay, when you see the suffer partitions are a lot, the number is a lot larger than what you can actually handle, and when you coalesce them, at least leave this number of partitions for me so I can actually execute other things in parallel. And the default parallelism is the number of cores you actually have. In addition to another property called initial partition configuration, which is saying, when you write the shuffle, pay attention to this particular property, which by default is 200. So it's going to write those 200 partitions before it decides to say, I'm going to go ahead and coalesce them into number. And how does it determine how many partitions it's going to coalesce to? Well, that depends on this particular property over here, which is saying when you coalesce the partition, make the partition size to be 64 megabyte. Now you can normally increase it to 128 megabytes if you have a lot of memory, or you can upgrade to 200 with fixed. That depends on the size of the cluster and how big it is. In essence, is the AQE configuration setting that you actually have to start playing around with it. And you can always, enable it, disable it, which is a great part of it. So that's number one. Adaptive query execution is a huge, huge performance improvement in 2.0, and a lot of people are using it. They might not be using it in production, but they're using it in dev. They begin to see the benefits of it. And then when we actually ran some benchmarks on the large TPC data sets of 1 terabytes and some of the TPDC queries, both with statistics turned on, with and without adaptive execution, we actually saw a magnitude of 2x improvement when it's enabled and when it's disabled. So I'm just not waving my hand. This is what the Spark community has done, along with Databricks and everybody else, to make sure that this is a feature that you guys can actually use. So that, in essence, is the adaptive query execution. Talk about, which along those lines is the dynamic partition pruning, which is the second big performance went into 3.0. And the whole idea, the whole premise behind the dynamic partition pruning is that, what if I can use the results of one query from my right-hand side join and feed it dynamically at runtime to the other part, so that I don't have to read too much data. I can just read the data that I need. In essence, read only the data that you actually need on either side, all right? That's the whole premise. And these queries are quite important in your data lake, in your warehouses, or you build large data lakes. For star schema query, where you're actually doing a join between a fact table and a dimension table, and you want to be able to actually prune and only read the data that you actually need. And this also gave us a huge performance gains in our TPC Denmarks. So how does this work? Understand the dynamic pruning is. And people kept on doing this. Static part, people do that in 2.x as well. And the idea is that, let's say you actually have a filter and you are executing this particular query called select asterisk from cells where your store ID is equal to 5. What Spark 2.x will do is that it will filter and it will do a push down predicate, right? If it's a Parquet source or if it's a database, it's going to push it down to the data source. And you say, well, you have partitions or you have indexes if it's using a relational database at the data source, and so filter out and just give me all the data where the store IDs match. Push down. That was all part of 2.x. And what happens is that it's going to go down and it's going to only read the partitions that have the store ID equal to 5. And when you partition the data on high meta store or in Parquet, you add additional statistics like, what is the min value, max value of the store ID. So if you're since there's no indexing in data like or in Parquet, what you're going to do is if your store ID is 5, you're only going to read the partitions that have a store ID is less than 5 or greater than or equal to 5, and you just read those partitions, and you'll filter it up and then send it back as a scan. So that's how static partition pruning works, and people use it today to great effectiveness and great performance gains. Unfortunately, these queries don't work with star schemas, as I say. And star schemas are quite common in large data lakes and warehouses where you're actually joining a large fact table with a dimension table. And you're doing a filter on the dimension table by New York City and getting the store IDs and then doing a huge scan on the left-hand side. And this filter is acting quite efficiently on the smaller table, but not on the greater table. And what you end up is getting a huge, huge performance drag. And the way people solved that problem was table normalization. That was a very common practice and is still a common practice. So if data analysts and data engineers see that these are kind of the queries that people are actually executing quite often, what they normally do is they normalize the table. They will do a big select from those two tables, we'll create a particular join and we'll create a new table, and then use that, store it as a separate table. So next time you actually do a query, you're going to go through this results. There's a problem with that. And the problem is twofold. One is that the constant change in the universe is data. Data is going to change. New data will come in. When new data come in, new store IDs will come in. New cities will come in. When that come in, you got to update this particular table. Now you have two problems. You got to update the table. You got to redo the query, and you have a lot of duplicate data scattered around all over the place, and it's error prone. And so the way dynamic partition pruning addresses that is at the physical level. What I'm going to do on my right-hand side, I'm going to do a select on my New York City on the dimension table and get all the store IDs that I actually need for New York. During runtime that the result brought from my dimension table with the store IDs is less than 10 megabyte, which is the threshold broadcast. What I'm going to do is I'm going to inject this particular filter with the results dynamically on the dimension table, the larger table, at the fact table. And if the fact table for some reason is either partitioned or indexed using Z order, or it has got meta store data statistics, then the result of this particular store IDs will benefit a lot because you're only going to read the partitions or you're only going to read the indexes that you actually need. In fact, you actually scaled down the filter to a small number of partitions you're going to read. And then effectively, you will be able to do a hash broadcast join with a larger table. And that's what partition pruning is. And then we saw also, as we saw with AQE, the number of improvements in the TPDC benchmarks quite a bit. And this now has been enabled for a while, and people are actually using it both in development and also in production. And this is enabled by default. So this particular value, enable dynamic partition pruning enabled by true. And if you don't need it, then you just disable it. So that's item number 2 in terms of performance. The third bit is the join hints. And join hints existed in 2.x, where you actually are given the control and the command to instruct the optimizer, don't use what you think, what you have come up with. I want you to use this particular merge, or I want you to use this particular join compared to the other ones that you might come up with. And so in 2.x, we had broadcast hint join. You could influence the optimizer to give, hey, do use a hash join because I've increased the size of my threshold. And in 3.0, we sort of included this new, actually provide to you SQL queries and your data frame query to say, do a sort merge join, do a hash join, and do a nested loop hash join. Now, you have to be careful with these things because, the adaptive query execution is pretty smart, to figure out, what's the right join you actually need dynamically. But if you want more control, and we developers are control freak, we want to control things. And so we give you the benefit of doing that, or we give you the benefit of saying, trust Spark, it will do the right thing for you. And sometimes it does the wrong thing. And so this is where you actually intervene and they take control. Now, in order to understand what these sort merge means, you have to understand what these strategies are, right? Spark, since 1.x and 2.x, had initially 4 join strategies that it had the algorithms for. But because of some performance problems, it fell out of favor with shuffle hash and nested loop hash. But now, because of some improvements, we have reintroduced that as part of the manual way that you can actually hint Spark to use those. So let's look at each of these. The sort merge join is probably the most common that you probably have come across. When you go to the UI, you will actually see, sort merge, then he actually does a join. And this is a very common search merge join when you have 2 large data frames or 2 large tables, and you're doing a join with the left-hand side and the right-hand side are large, and it's quite effective. And it has to be, it is shuffled, it's sorted, and it goes through 1 row at a time and then merges them, which is quite effective. If your table size is small, then the sort can be actually be slow. So it's best and more optimal when you actually have large tables. The broadcast hash join, which is very popular and a lot of people use it, when one side is a lot smaller than the large size, which we actually saw in our example, and requires no shuffle, it's very actually fast because what you're doing is you're taking the result of that particular filter or hash or whatever result is, and you're broadcasting to each and every executor on the cluster. So each and executor has a copy of that in memory, and then now you're actually doing the quick join. Is the shuffle hash. And shuffle hash is very similar to sort merge, but the only difference is that it doesn't do the sort. There's no need to do the sort. It needs to shuffle, however. And you can handle large table as the other one. But the only problem is that it loads the table in hash. The keys and if your table does not fit into the memory, you could actually end up either having a data skew or you might end up using OAM. So these 2 are quite popular. These 2 next to have fallen out of favor, but there's much improvement in using shuffle hash, and you can actually use it depending on that. The last bit over here, which is the most least performant, is the shuffle nested loop. And what the shuffle nested loop does is it goes on both sides. It requires no join and no keys. It goes through each and every key to figure out where can I actually do it. Think of it as a Cartesian product, right? And this is probably the most expensive one because you can actually end up having n squared or a big O of n squared, because now you have n number of keys here, n number of keys, and you can compare each and every key. But it's there, and so we give you the ability to shoot yourself if you are suicidal. So there you are. So those are the join strategies. And then you can provide those SQL join hints by selecting, using the SQL syntax by saying, do a broadcast join for table A when I'm joining A with A of key with the second table. or select use the short merge join, or I can do a shuffle hash join by providing SQL hints, or I can do the shuffle head replacement join. So those can be done programmatically to give you the more control to override what AQE might think. And this normally comes after you've done a lot of investigating to say, oh, AQE does a really good job. I'm going to tell you to do a broadcast join because I know exactly how much my data is going to be because I worked on it. So this would be sort of one way to manually control if you actually wanted that. And you can do that both in the SQL syntax, whereby you can actually provide the shuffle, or you can do that at the API level. So in your data frame, when you read one table and you read the table, another table, and you want them to do a shuffle merge, then you can say df.hint, do a shuffle merge, and then join that particular table. So that the APIs now are quite readable, they are quite digestible. You know exactly how to read them, and you know exactly what you're actually doing. And so that has been the second or the last one that has improved Spark 3.0 quite a bit. And those are the big nuggets I talked about, because I don't want to go into all the other details, all the minor things. But these are the three big SQL performance where the 40% pie chart goes into the work. Now, I want to shift my focus a little bit and talk about how Spark 3.0 has been all along easier for developers to use. Now, we have to look back a little bit to see how Spark really evolved. And those of you who have been with Spark for a long time, the Spark 1.x were all RDD-based. And RDD-based was very low level, right? You really, really had to sort of understand Scala, and you had to read really query syntax to figure out how the RDDs work. And conceptually, for people who were new to Spark, it was quite daunting. And then when Spark 2.x came over, we sort of introduced a high level of structure in Spark, which was data frames and data sets, right? And then we actually had a uniform APIs across all the Spark components, and the machine learning, the structured streaming, the SQL, and the data frames and data sets had a uniform API. They used data frames or data set. And those were structured. Those were like tabular APIs that you actually are used to if you're using, Pandas, or if you are looking at a spreadsheet, you look at the structure. And the structure in Spark actually helped quite a bit. And so we have all along always strived to make things easier for Spark and for developers like you to reach those APIs. And so the new addition to this particular Spark 3.0 is the SQL explain format. Now, if you are old user of Spark and you're curious to know how did your data frame or how did your SQL query went through their journey, you would normally do something like Spark SQL.explain. And what it actually gave you was a toilet roll that goes this long with all the physical plan, the analyzed plan, the optimized plan, with all the particular data. And those of you who have looked at this particular old plan explainer probably have scratched your head, oh my goodness, how am I going to make sense of this? And this is can be quite daunting for someone who's actually new to it. And when they say, I don't know what's going on, how can I figure out? And somebody told you in Slack, hey, just use df.explain, format that, and then you'll get exactly. And what you get is a dump of this thing as if you're reading assembly language. And that can be quite daunting. It's fine if you're in advance, you can actually know exactly what you're doing. But we didn't want to do that. We wanted to give the developer an option to give more granular how much data you actually want. And so in 3.0, what we introduced was new explain format. And explain has got 4 modes, and I'll show you what those modes are. And so when you do explain format, it gives you a very nice, very digestible, very easy header of what the physical plan looked like from bottom up, right? I scanned the file, I did a column to row, I did a filter, I did a select, I did a hash aggregate, I did exchange, and then I did a filter. And then associated with each of these Spark SQL operators, you have an index. It gives you more data or more information about what transpired at a low level for this particular plan, right? So you got a header, which is easy and digestible. You can look at it at high level, the tree, to see what your operators were. And then if you're more curious, you can actually look at the index to figure out what all those additional attributes were, right? Or if you did something like this for a small, select asterisk, explain formatted from where key is equal to this, you get this nice little format you actually use. And this in itself is quite easy to read. It's not that daunting. And there are different modes that you can actually do. And so you can do data frame explain and give a particular mode, for example, simple mode. And when you do a simple mode, you get a very high level view of only this. So you know that, oh, I went to the parquet to read a scan. I did a column to row, and I did a filter, and then I did a select. Very easy for you to figure out. If you did an extended, you get a little more explanation of all the different phases that you actually went through. And if you're a masochist and enjoy all the data, and if you're really a hardcore Spark developer, Spark SQL developer, you can actually use CodeGen to see exactly what data was generated at RDT level. And this is normally for advanced people. This is not for people who actually want to learn. So CodeGen is like reading assembly language. You know exactly what your RDT code is. So there are different levels of granularity in how much data you want and at what level and at what explainability you actually want. So that sort of brings us to the usability of how Spark keeps on continuing to increase the ease of use for developers. The second bit that I was introduced in Spark 3.x is the enhancements to the Pandas UDF, right? Which is a big, big boost for people who come from the PySpark community and people who are familiar with Pandas and they want to use Pandas UDF in their PySpark. How do they actually do that? Now in 2.3, with the help of the community and also with Databricks, we introduced this notion called vectorized UDF. And as the term suggests, vectorize is something that you actually take an entire batch and you on that particular batch. And the underlying vectorize was taking advantage of the PyArrow format that actually allows you to send an entire batch across to the executor to execute whatever you actually want. Now, the Spark 2.3 was based on Python 2. And Python 2 forced you in the annotations to specify what kind of computation you're doing, what's the input value is, what the output value is going to be. And it somehow made the code a bit more hard to read, and you actually have to know exactly what all those things are. And so what we did in Spark 3.0 is to take advantage of Python 3.0 type hints, which is a popular feature now among the Python ecosystem, whereby now you don't have to annotate your Python UDFs with, this is going to be a group map, or this is going to be Pandas scalar, or this is going to be group map. All you do is you use the Python type hints to see what your input is going to be, whether it's going to be data frame or series, and what your output is going to be. So in the scalar, you're probably going to have a series because you only want one set of data. And then you very easily just do your usual select Pandas UDF and just do your computation. Sort of one big improvement where the Pandas UDF in Spark 3.0 using the Python underlying 3.0 gave you the ability to write your code very easily so people can actually read it and know exactly what's happening. And there were other additions. For example, there were Pandas functions which were added as part of PySpark, as part of the group map. So you just do from SQL Spark include this particular function, and then you can actually do apply in Pandas group by with your Lambda function, and then you don't have to say what your scalar type is. It knows that you're actually doing a group operation, and it's going to take Pandas as an input and return you Pandas data frame. So that is a huge, huge improvement. If I had to give you the code in 2.3, this would be scattered with all the annotations and it would be sort of hard to read. But this is clean, it's easy, you know exactly what you're doing, right? Now, there is a whole list of other Pandas functions that got included as part of PySpark API. And as usual, I have a blog over here, and there's a Spark AI session that we actually did where we go deep dive into it. And if you're a Pandas fan, and if you're a PySpark fan, and you love PySpark, and you love Python, I would urge you to read the blog, and I would urge you to follow the particular link to hear the commuters say, why do you actually want to use that? So it's a huge, huge gain. And then finally, my favorite, that has really improved the usability is structured streaming. Right, structured streaming has come a long way, right? Initially from dstream, which was very much batch oriented, but there was a lot of work that you actually had to do to manage the queries yourself. Structured streaming was a huge, huge improvement in terms of you don't have to worry about that. Let the underlying Spark engine consider and take care of all the batch and incrementation of all the queries for you. And in addition to that, in 3.0, we added a new tab called structured streaming tab. So when you have a Spark job that actually does structured streaming, what will happen is that this new Spark will create this particular new tab. And when you go to this particular tab, it will have two sets of tables. The first will give you all the active queries which are actually running, and all the high-level runtime statistics of what the queries are doing if they're active. And they'll give you the status of all the queries that had completed and all the underlying query names and what it took and how you took a number of records. So at a glance, when you go to structured streaming, you get a high-level view of, oh, this is my active query. This is what's actually doing. The duration is 1 minute. Maybe there's something wrong here. This is my average throughput. It's a good way to look at that. And then when you go to the completed queries, you actually have an idea. But what about if you actually want to find out a little more about what's going on in this particular query? So you can click on this particular item over here. And when you click on that, what you get is a more detailed view, more granular view of all the metrics that it's dealing at runtime. Input rate, what's the process rate, how many rows you've already done, and it gives you a histogram as well, a number of input rows is done, and then actually gives you this really nice duration of all these different queries as you can actually see. And this is actually happening dynamically, right? And one of the great things that we have added, because people couldn't find documentation on structured streaming or how to use the UI or how to annotate the UI. And I've covered an entire chapter in this particular book about how to actually use the tab UI. And when you click on that, what you get is as I say, the streaming UI that gives you input of each and every query. And you can actually look at the current rate. You can actually look at the process rate. You can look at the input rows, and so on and so forth. So this is actually a huge, huge win for people who are writing ETL jobs, who are writing structured streaming jobs, and want to know, what's going on behind the scenes, what's happening under the hood. So this is actually a huge improvement in terms of two things: the ability to observe what your streaming jobs are doing, and the ability to use them. And we have made progress from 1.x to 2.x in how structured streaming is used. And this is actually a huge, huge improvement. So that, in essence, sort of covered some of the usability features, and I'm not going to cover all the other ones because some of them are actually minor, but don't matter. But these are the things that I think matter quite a bit for people who are actually sort of either new to Spark or are making the transition from 2.x to 3.0 to see what are some of the benefits that you really should care about. Now, I want to move on to a very important bit of information. I think when I was talking to Jose, Jose said, one of the things that people might want to know is that, should I migrate from 2.x to 3.0? What are things that I should consider? What are the gotchas, right? And we normally, when I talk about I'm talking about Databricks and the community and the larger Spark users care about compatibility and the migration considerations, especially when you're actually making changes from 1.x to 2.x to 3.0. And Mathias Zaharia is religious about breaking changes. He does not like to break any changes, so he tries to minimize the change in the API. We only break changes if we go from one major release to another major release. And if we do that, we document that to the point of nausea, where people can actually find out exactly what's going to happen, what's going to break, what the behavior is. And that has been the philosophy in order to actually make sure that people feel psychologically safe to move from 2.x to 3.0. So what are some of the high-level nuggets that you should take away from this particular presentation in terms of migration? So Spark 3.0 now builds only with Scala 2.12, right? And so if you have other libraries that you actually load in, which were compiled with Scala 2.11, make sure you compile them with Spark 12, Scala 12, so that they're compatible with your job. We have completely deprecated Python 2, and that's the case in the Python ecosystem as well, right? And so if you're using Python 2, this will be a forcing function for you to consider, hey, I'm not going to use Python 2, I'm going to use Python 3 because I get all the benefits of PySpark and all the typing functions, all the new stuff that has come with Python 3. And we've also extended the Spark ability to work with different versions of the ecosystem for Hive and Hadoop, right? So we support 2.7 with Hive, which is the minimal version of it. We support Hadoop 2.7 with Hive 2.3, which is really the default one. So if you went to spark.org, you download the binaries, the default build of binary is going to be Hadoop 2.7, Hive 2.3. And it supports, Java 11. And the reason it supports Java 11, because if you have your Java home to be pointing to Java 11, it used to be that we require Java 8, but you can actually have Java 8. But if you wanted to take advantage of, for example, the recent garbage collection G1, then you probably want to use that with Java 11, which is actually the default right now. And we also support Hadoop 3.0 versions and Hive 2.3. And these are all the different versions of the metastore that you actually want to consider. If you're working with different metastore, all these are compatible with Spark 3.0. The biggest thing we've actually done in order to make sure that people are psychologically safe, people are well informed, and people know exactly what will happen when they move from Spark 2.x to 3.0. And this is not to scare you or anything, but we want to make sure that we have documented enough information for you that you can actually make a decision. And if there are any breaking changes, if the behavior changes, we'll let you know that, oh, by the way, you're using a 3.0 version, the behavior is this. If you want to use the 2.x version, there is a way you can set the flag to use the legacy one, and you can go on. And in order to do that, this is what we have done. We have actually created a migration guide for each and every component, and we have detailed information about what are the changes for each and every library, what are the changes that you have to worry about, what are the changes that you shouldn't care about, what are the high-level things that you might want to consider with each and every component. And so that has been, the one of the greatest asset that has actually come out from the community is to document all the different compatibility issues with each and every component. And there's a migration guide for each and every part of the Spark that you might want to consider. Some of them probably won't matter to you. Most of them are very low level. But if something happens, you will actually see it, and you'll be able to go over there and point exactly, and then get the suggested discussion. So that, in essence, really, really sort of covers the high-level overview of Apache Spark 3.0. What are some of the performance improvements? What are some of the usability functions that were important to make the Spark reach your API? What were some of the migration aspects that you should actually consider? And the last thing I want to end up the discussion with, and I think it's actually quite important for us to know, is the Spark ecosystem, right? Now, if you look at the history of innovation over the years, you know that since the advent of the open source community, innovation actually happens in collaboration. Isolation. When you happen in isolation, you get proprietary stuff. When you do innovation in collaboration, you get a fair amount. 100 people working on a problem is far more productive than 2 people working on a problem. And so because of the fact that Spark 3.0 an open source project, a lot of people are actually working on it. And because of the fact that it is an open source project, I can actually build things on top of the Spark as part of the ecosystem, because innovation begets another innovation. And the ecosystem has actually evolved quite a bit from 1.x to 2.x. If you look at all the other components that work in conjunction with the Spark, it's actually quite phenomenal. And so I'm going to talk about 3 important projects that actually have emerged in the last couple of years, and are going to continue to make a huge difference as we have entered in this dawn of data, where data is central to everything, where data is very data-centric. And the first one I want to talk about is Delta Lake. And you can see I'm wearing a Delta Lake t-shirt. So it's acid on Spark, and it's a reference to a Beatles song called Lucy in the Sky with Diamonds, LSD. So Spark on acid. So that's what Delta Lake is. Yeah, you want those t-shirts? Okay, you'll have to buy them. I can't send them, but I will. What I will do is I'll pass it on to Matej and Michael Ambrose to say, hey, listen, we should send some of these t-shirts to Bogota, so
it will be great.
So they can actually wear Delta t-shirts. And if you guys want, and so if you guys, so I'll make a note of that.
Yes, it will be great if you can introduce us to him, so we can bring him to the meetup as well. That will be awesome.
Yes. And so,
Thanks.
So if you have been sort of following some of the social media and some of the technical blogs in the last 6 months or a year, Delta Lake has come into the front as an open source storage layer that brings what I would call ACID transactions to Apache Spark. In other words, Spark now can build reliable data lakes and handle your enormous big workloads with comfort, with reliability, and you get the ability to do your streaming and batch jobs to build your enormous data lakes. And those data lakes are fairly reliable and fairly structured, so then it can be fed down the stream for business analytics, or it can be fed down the stream for doing machine learning. And that's sort of the overview. So we announced that last year with a lot of fanfare in the community, and there was a lot of excitement within the community after we said we're open sourcing this particular data format based on Parquet, and we are donating that to the Linux Foundation. So it is under the governance and the guidance of the Linux Foundation. And we continue the community to help us sort of build on this particular format. Everything's built on open standard. And the whole idea behind this particular new standard is for you to build enormous data lakes, because data lakes are huge. They can be swamp. But if you can't build reliable data lakes, it can be a problem. And I'll give you all the reasons why. In the absence of Delta Lake, what are some of the problems if you have been involved in building large pipelines? So one is based on open-based Parquet format, right? And so you use the Parquet, there's nothing proprietary. What we do is, in addition to a Parquet table or Parquet files, we create a transaction log. And the transaction log keeps track of what are the transactions actually happening. And so for each table, there's a transaction log associated with that. So that allows you to do very much similar to what you would actually get if you were doing a relational database transactions on a particular table. And so these, because of the transaction log, this gives you the ability to build reliable data quality, and also gives you a huge performance as well. And that sort of brings the ability to use large data warehouse transactionality in your data lakes at scale. So your data lake can actually scale, but you also get a lot of reliability. And it's all based on an open source format called Parquet, and it works brilliantly with Spark. That's the beauty of it. So that was the introduction of data lake at a pretty high level. But in order to appreciate and understand the value of data lake, and I'm not trying to do a selling job here, I'm trying to really sort of address what they genuinely takes care of. And so you have to understand what are some of the challenges that people who have been building data lakes from the early days. Data lakes is not something new. I used to work at Hortonworks, and I remember, they were the one who coined the term data lakes, right? They told the swamp, just dump everything in there, with structured or unstructured, you don't care. And then it's like schema on read rather than schema on write. And so anytime you need data, you would actually do that. It turned out that it becomes very costly when you want to do certain kinds of queries. So what are some of the challenges? And I think there are about 10 of them that we actually identified. A lot of customers actually agreed with us. And this was, it's hard to append data, right? And the reason is that when you're adding newly arrived data, it can lead to incorrect reads, because as you're appending data and the reader is reading that, you could actually have inconsistent data. And those of you who have built this particular data lakes have come across this particular problem. And there are various ways, there are various strategies that people use that, they create a copy of it, they use duplicate logic to figure it out, but all that becomes cumbersome over time. So the one problem is that it's hard to append data and consume data at the same time, because normally you will have some BI tool, or you'll have some jobs that are actually reading the data while things are pending, and you can actually have incorrect reads. The second, obviously, is modifications is difficult, because we are living in this era of GDPR, and especially if you have a European company where they're very, very much concerned about private data, or if you're in California, CCPA, you won't be able to actually make sure that you can delete a particular row or particular column, or change a particular row or particular column in isolation, right? And the way you could actually do that today without Delta Lake or transaction is that you would actually take a table and you copy it, or you lock the table and you copy it, and you update the rows and the columns that you need, and then you write back. And so while you're actually doing all that, the readers can't really read because you actually block them. So it becomes quite costly in order for you to actually do that, for Spark to do that, or even for you to manage this extra layer of job or thread that's actually doing that, and become actually brittle and becomes a little more complex. So you don't want to deal with that. The other thing is that when you're building data pipelines, your jobs could fail midway, right? Halfway down, it's written part of the table, written part of the files, and it actually fails. So what do you do now? Now you have to figure out, okay, I'm going to have another job that will come up to figure out where it stopped, and I'll try to amend the data. While that is actually happening, what happens when somebody is actually reading the data? So partway job fails can actually create a problem. I'm not saying there's no solution for it. There's always a solution to a particular problem, but it's just an extra added functionality and complexity that you add that's not actually needed. And by the time you create a very sophisticated data pipeline, you're having a nightmare to figure out, what if this thing goes wrong, what if that thing goes wrong. The second thing is that how do you actually deal with today? Most of the people in the real world, in the cloud and premise, are dealing with two sets of data sources, right? People streaming data is actually coming up, which are transactions happening online store. You have static data coming from somewhere else that you are doing ETL. How do you keep track and mix the data? Well, you might say, Jules, you can actually do the Lambda architecture, which is not bad, right? It was quite popular at the time, where you have a different logic for streaming and a different logic for batch, and then you sort of merge the data when nobody is doing anything at home. Those can be not realistic in the scale above. Today, we need things instantly. Streaming, all that is part of real time. So having two modes of execution to make sure that the underlying data is safe and coherent and consistent is difficult to manage with Delta Lake. The only way you could actually do that was either completely lock everybody out, have your Lambda architecture do all the mixing and matching, and then open it up, which can be quite cumbersome. And then how do you deal with historical data? In other words, after you have appended the data, now you have actually moved the historical needle. And if you have given that particular table, which you have just appended it to machine learning, that created a particular training set for that particular model, if you want to retrain that, you can't really go back, right? Now, one way to do that, you take that, make a copy of it, attach a version to it, and then give it that to the machine learning training algorithm to say, next time you need that, go to this particular location, because that's what the data was. Now, if you have hundreds of different models and each is using different version, you can see that it becomes a bit intractable. So it's costly to keep historical data. And as your table increases, your Hive metastore increases, the metadata, the tables, the statistic, everything associated with that increases astronomically. And so now you have to manage this enormous amount of not only the tables, but all the metadata associated with that. And some of you probably have heard about these too many file problems, right? So when you're doing streaming, you're actually creating these delta files in your Parquet, and Parquet creates these files, and now you end up having too many files, right? And on a file system, you have just too many files. So if you're doing the list of all that, you end up having a huge performance when you're reading millions of files. And then how do you actually deal with fine-grained access control at the enterprise level. Because if you're a security company and if you're a financial company and you have sensitive information on your Delta Lake tables in your Parquet files, how do you control that, right? How do you make sure that only certain people or certain jobs or certain IP addresses or certain admins or certain machines can access your particular Delta Lake? So that's an imperative that's quite common in Delta Lakes that to be addressed. And then finally, you got the performance. I mean, you have too many partitionings. You're going to have a problem dealing with all the number of partitions you actually have to read. And then how do you deal with data, right? Data changes. The only constant in our universe is change. Change happens every day. Every second our cells are multiplying. Every second we're getting old. Every second data is changing. How do you keep up with inconsistent schema? Your data yesterday, a table had 5 columns, but somehow things change in the world. Your business problem changed, and now you have 3 columns. So how do you compromise between the old data and the new? How do you enforce the schema? What do you do if you now accept the new schema, but if you had to read the old schema, old data with the new schema, what happens, right? So you got to deal with data quality issues, and how do you enforce the schema? So that's a laundry list of some of the problems that existed. And these problems are not something we just made up. I think those of you who are data engineers in the crowd have probably dealt with this in your own particular way and have had to somehow also deal with the complexity added to it as well. So one of the things that the open source Delta Lake allows you to do is that for items 1 through 5, you solve their problem by ASIC transaction by putting a transaction log. So when you have a transaction log, you know that if you particularly modify a data, you can have multiple readers and writers because it uses the MVCC, which is multi-version concurrency control underneath, and uses optimistic concurrency. I mean, there are two. There's pessimistic concurrency where you lock everybody out, or there's an optimistic concurrency where you give the benefit to whoever actually writes the data first. And so we make sure that you either get a complete write or you don't get it right. So if you do a read, you're always going to get the read of the data that existed, and you won't get inconsistent data. So that sort of ASIC transaction for each table allows you to address item number 1 through 5. For 6 and 7, because of the proof of concept, we use Spark underneath to deal with all the metadata. Right? Spark is good dealing with large scale of data. So that gives you the added benefit by just using Spark to handle with metadata in parallel, massively parallel, because Spark is embarrassingly parallel compute engine, a processing engine. And then the too many file problems and the rest of the thing is something that we added on top of the Delta Lake, which we call managed Delta Lake in Databricks, that deals with auto indexing, right? So we have this command line tools called vacuum and optimize that you actually run asynchronously. So he takes all the partitions that you have, all the small bars, and he coalesces that into, and then create versions of it. And so anytime you actually need to go to a particular historical version, you can go back to that particular version, right? And we also added fine-grained access control for that. And the schema enforcement evolution is now part of the open source where you get the data quality. So on Delta Lake 0.7, which is open source, we included DML commands such as merge, update, insert, upsert, and other schema validation. So if you actually have matching schema, you're going to get an error, or you can override, say, go ahead and merge my particular schema. So going forward, accept these new rows. And if you had to go back and read the old data version with the new schema, just fill the other ones that don't exist because you won't have those columns in there with null data or whatever value they actually want. So that, in essence, is really this new innovation that has spurred from Databricks, which is the Delta Lake. And what Delta Lake has begetted, or what it has actually led to, this new data paradigm called Lakehouse. And you can think of it's an evolution of data lakes, which was really a swamp of unstructured data that could be anything on it, to a more structured data with Delta Lake that allows you to give ASIC transaction, allows you to refine the data as you move along in your pipeline. And then you create this lake house, which is your structured and unstructured data sitting over there with a high Delta engine that actually does the query, which is underneath a Delta Lake. And now you can actually have applications sitting on top that can consume the data, whether it's business analytics you're doing, whether you're machine learning or whatever you're actually doing. This is sort of the new data paradigm that has actually emerged. And then at the very large data conference last month, we published this particular paper, which was actually quite well received. And I would urge you, really, I would implore you to read that, and you will see what I've said today is nothing but what has been articulated there at a very fine technical, credible level. So make sure that you actually get this particular paper. I'll share this particular presentation with Jose, and you can share with the community. And then what this has resulted is that now you have this external ecosystem partners, where data warehouses, which are actually now using Delta Lake to read the data and write data back. So you got all these Spark connectors that Hive 3 can actually use. Spark can read back and forth. Presto, right, which is an SQL engine by Facebook that allows you to read data from any particular table, has a connector for Delta, Snowflake, Amazon Athena, Amazon Shift. So you can see this Delta Lake connector or Delta Lake storage layer as an open source form is actually it's gaining traction. It is being used quite a bit. And if you're really interested, these are the 2 links that you can actually find out more about it. There are loads and loads of tutorials we have written on Delta Lake. There's a lot of technical talks that goes deep into how the transaction layers work, how the enforcing of evolving of schema works. We have provided notebooks associated with that. You can actually just upload that in your community edition, Databricks community edition, use them. And so these are a good way for resources for you to get used to with what Delta Lake is, what the promise is, and where the future is going in terms of building massive amounts of reliable data lakes with Spark at the center of its processing engine. The last project, second to last project is Project Hydrogen. The name's a bit funny, but what is Project Hydrogen is based on some historical Adam, I guess. Now, initially, Project Hydrogen was introduced in Spark 2.x or 2.4 to be more particular. And the whole idea from the community was an initiative to say, hey, listen, Spark is a great engine, and we want to be able to have deep learning frameworks such as TensorFlow or PyTorch to be first-class citizens to support as part of the machine learning framework, right? So that was the premise, that was the vision of what Project Hydrogen was. And so what we did was with the community work on this Project Hydrogen. And the Project Hydrogen had 3 phases. The phase 1 was introduced in 2.4. And the reason it was introduced in 2.4 was to address this unfortunate incompatibility between execution models. If you look at Spark's execution model, and we have discussed this quite a bit, all the tasks that emerge out of this job into stages, into tasks, execute independently, right? So it's embarrassingly parallel, pathologically parallel, massively scalable because all the tasks are running in parallel. And should one task fail, if this particular task failed, it can be rescheduled on another executor and the job continues from where it started and goes on. In a distributed framework such as, say, deep learning, such as Torch, PyTorch, or TensorFlow in particular, if you have a distributed training, the individual tasks have a lot of complete coordination and communication. Because if you're computing a loss function, let's say you adopted a loss function on stochastic gradient, and it's computing gradients on that particular task, it's going to share all the gradients and all the weights to the next executor. And so there is this round robin sharing of information so that it can actually start computing the act. And those have to sort of coordinate and communicate, which is kind of different from the parallel execution mode. And if a task crashes, then you have to run all the tasks again and start from where they left off in terms of their coordination, in terms of what weights were computed. So the execution models were different and incompatible. And so the solution in 2.4 initially was to have what we call the gang scheduling. And gang scheduling was based on how the MapReduce execution model works. Now, those of you who have actually written a lot of multi-threaded programming and you want to coordinate threads, there is this utility, or there is this a technique called barrier. And before you launch all the threads, you create a barrier, and then you say, okay, here's my barrier for these 5 threads that are going to execute in parallel. But then when the threads finish, they're going to register that I finished with my barrier, and so the barrier will waiting for all the threads to register themselves. And after all the threads they've registered, they're finished, the barrier is complete, and now you have finished that task. So the idea was very similar, where you have a gang scheduler for barrier execution. So when you're doing data preparation or when you're doing feature engineering, you can actually take care of the Spark's embarrassing parallel execution mode. And when you're doing training for deep learning frameworks, you schedule your jobs using the gang scheduler, and the gang scheduler will wait for all the tasks to finish, and they will communicate what gradients they've computed with each task. And when they are done, now you can take on the Spark's parallel execution for either parallel inferencing, or you've computed all the inferences and you want to write out to a disk. So that was actually thing that was introduced in 2.4 at a very low level, RDD level. In 3.0, the problem was that all these particular frameworks were using deep learning workloads who could actually use GPUs for doing tensor arithmetic or doing computation, right? And they couldn't use the accelerators because Spark didn't know about those. You would have to do in CPU, so you really are actually slow. And the popular cluster managers that Spark supported, both in 1.2.x and 3.0, like Yarn and Kubernetes, could support GPUs, but Spark was not aware of the fact that I can actually use GPUs for my particular application. And so 2.x, though supported these cluster managers, it could not somehow at application level say, oh, for this particular application, you use GPUs in my cluster for doing computation. So what we did in Spark 3.x was that in order to benefit from these workloads in deep learning and signal processing, support standalone Yarn who actually support GPUs, to request the resources at the application level through some configuration, right? So if I'm reading a Spark on Kubernetes and I'm using CUDA and I'm using Rapids, and I can actually tell Spark detect all the GPUs that I have through this configuration, and then do that at the application level, right? So the only caveat over here is that I can only do that at the application level. So I have to do that at the time when I do Spark submit, or when I submit the particular job. And we only support GPUs right now. There is future support to be done for the GPU and other hardware accelerant. And there are tasks of JIRAs being filed to do more granular support at the task level, at the stage level, the job level. Right now, you have to do that ahead of time at the Spark application level. So that's actually what's happening in terms of the ability to take care of the underlying scheduling of 3.0 hardware accelerant. And then if you look at the executor's UI in Spark 3.0, what you will see is that the resources now tell you that I'm using GPU 0 on my driver. And if I have more of those, you'll see those GPUs. So you know that it's actually using the Spark GPU underneath. So that essence is the Project Hydrogen. And then finally, last but not least, we have this thing called PySpark improvements called Project Zen. And this Zen was actually announced by Matthias Zaharia and the community at the Spark Summit, virtual Spark Summit we had in June, whereby we wanted to make things a lot easier for PySpark and for Python community to use Spark very easily. And there were 5 high-level initiatives that sort of launched these particular improvements. And one was, let's redesign the PySpark documentation so it's easy for you to find something. Let's rewrite all of the Python APIs to have type hints in there so people can use type hints. incorporate some sort of a data visualization with it. And then last but not least, let's standardize on the warnings and exceptions that PySpark generates when something fails. And I know I've looked at the stack trace. When my PySpark job fails, I get a toilet rim, right? I get a toilet rim of all the exceptions. And it's got exceptions from PySpark, it's got exceptions from the JVM, it's got exception all they want. And some of the exceptions you can't even read. And you don't know where the root cause is, right? It's like a toilet roll. Somewhere there's shit, right? But you know where it is. And so you have to go through all that. And so the idea over here was to somehow only give you what you actually need to say, oh, this is where the exception is, here where the root cause is. And so that's actually a huge, huge improvement. And this is an ongoing effort that we actually announced at Spark Summit to the community. And you can actually look at the current documentation and actually tell you what that is. And yeah, let me run that. So when you go to the Project Zen, you'll get the user guide, and you can actually, everything is sort of very much it's got Python hints, it got a lot of code snippets, uses pandas function, group map, everything you actually wanted to know what the API reference is available for you, is discoverable, and it's much, much easier for you to find. And it's a lot friendlier for people who come from the Spark community as well. And so that, in essence, is today's presentation. And as you know, every year we have two major conferences, one in San Francisco in June, and the other one, normally we have it in Europe. Because of this unfortunate circumstances, COVID-19, we had our virtual conference in June, and we had 70,000 people attend from all around the world. It was phenomenal. It was amazing. We had to sort of pivot that in like 1 month, and we were really worried how this is going to turn out. And it was one of the best conferences that I've attended. I've attended 16 conferences since the early days, and this was like, I don't know what's it going to be like having a virtual conference. 70,000 people registered for it, and there were at any point the best virtual experience that. And so we are trying to do the same thing with Europe, coming up on November 17th. Initially, it was supposed to be in Berlin. Unfortunately, we can't go there, but we're going to do that virtual. So the data registration is open. It's free. Please feel free to register, save your spot over there. And I'm going to be announcing the agenda coming up very soon. We finished building the agenda. I'm writing a blog about it. So the agenda is going to be published in coming days. And so hopefully we will see you there in November. And then finally, I want to thank you. I want to thank you, Jose. I want to thank all the people in Bogota with the support, with keeping the Spark flying down south, sharing that with the Latin American community, and happy 10th birthday from Tesaria to the Spark community.
All right. No, we definitely need to thank you, Jules, for this comprehensive, very comprehensive, I will say, review of Apache Spark 3.0. I mean, we already had a 10,000 foot overview of the new features a couple of meetups ago, but no, this is nothing compared to that event. We definitely gained a lot of insights from your presentation. We are kind of running out of time, but we wanted to have like a short panel with some participants from Bogota, from the community, because we want to relate about the specifics of the framework. We also want to understand a little bit better how did you start it with the framework? What do you think? And this is more question from me. I think the changes they made to Spark in 3.0, they are quite important. And it seems like that unified engine that was like the initial goal is materialized with this release. So I want to ask you if you think that there is a major switch in the philosophy of framework. You are pointing What is that like future of Apache Spark in the short term, let's say 3 years, 2 years, and what do you think is the impact of those features released in 3.0?
I think, if you were to ask this question to Matthias, he will tell you actually the same thing. He will tell you that since the early days of Spark, we had two things in our mind. We want to make this a unified engine, right? Because we want to make sure that we can actually handle all the workloads. Any new workloads that come up, we make Spark very easily be incorporated into it. And that hence the project Hydrogen was the ability to actually deal with deep learning frameworks, which we didn't have to make that as part of the engine. We say, we're going to have the APIs and then we'll have the engine actually take care of the scheduler. So in terms of the breaking changes, I don't think there are that many breaking changes. The philosophy of easy to use, intuitive APIs, great documentation will continue to do that, right? And whenever we introduce new features like we did for adaptive query execution and with dynamic partition pruning and with some of the join hints, those are major changes in the Spark sort of scheduler and optimizer. We normally do that by saying this is going to be experimental. And that has been right from the beginning. When we introduced Data Frames 1.3, I remember I wrote the first blog about RDDs and data frames and data sets. If you look at that, if you search Tale of Three APIs, you'll actually see that, is that some of the APIs were experimental. And so the philosophy is always that let's put something out there which is experimental, because when we create the JIRA, the community weighs in a lot, and the community decides what JIRA are going to go into it, and are they going to be breaking changes in the entire community. We don't decide, the Databricks doesn't decide that. The Apache Spark community, as part of the JIRA, decide, okay, these are the JIRAs that we're going to do that, and these are the things that are going to be accepted or not. And so we normally tag those as experimental. And then the next release, so for example, we released 3.0.1 last week, which are bug fixes to some of the things. 3.1 is going to come down the pipeline, and maybe some of the features that we have deemed experimental might be ready for GA, right? So for example, I didn't talk about Spark on Kubernetes, right? Spark on Kubernetes is huge, huge, huge.
Right.
It is an experimental right now. There is work done by Google, but I think by 3.1, it is a very likelihood that it'll be considered as GA and people will be able to use that.
Right.
So I think the philosophy is that listen to the community what they want, right? Let's discuss that among and file a JIRA for it. Let's decide democratically what are some of the improvements we want, and don't break changes. Right. We can't be like Facebook, fail fast and do what you want. No, we can't do that, right? Because this is a processing engine, a lot of things depend on it. So we have to be actually very careful. And even the breaking changes over here, you won't see that many breaking changes in terms of the data frames and data set APIs. There are things we have added on top of that. We haven't taken anything out. There might be a few changes in MLlib for, let's say, one hot index, or there might be some compliance issue with, say, how you actually do a trim for Spark SQL. But to answer your question is that we listen to the community, we figure out what's important, we accept the JIRA, we create a particular release, we tag it experimental, we get feedback from the community, we fix it, and then we release it as GA.
Awesome. Now that you mentioned Kubernetes, that's another question that I have for you. My understanding is with Yarn, you can actually discover the GPUs that you have in your workers. Is that also a possibility with Kubernetes, or do we need to wait for?
No, Kubernetes right now supports GPU, right? All the clusters in Yarn, you can request the GPUs, but Spark didn't know that I'm supposed to use the GPU, right? So with 3.0 now, through some configuration, you can instruct Spark that when you launch this particular job, when you do Spark submit, here's my configuration that tells me, that instructs me that this particular cluster has this many GPUs, use those GPUs, right? But you can only do that, as I mentioned, you can only do that at the application level. We have not. The next stage is going to be, can I actually execute dynamically at tasks? Because remember, when you submit a Spark job, the Spark application is going to be broken down into jobs. The jobs are going to be broken down into stages. The stages are going to be broken down into tasks, right? And so we want to be able to say, for this particular stage, use the GPU. For this particular task, granular, use the GPU. For this particular task, don't use the GPU because I don't need that. We are not there yet, but it is in the road plan. It is happening, right? That's why I said, if you look at my slide about what you can do today, is that you can do that at the application level, but not as granular at the job, task, and task level.
Awesome, awesome. And just
Yeah. So let's say you're using PyTorch or TensorFlow to do some visual detection, right? And you created a particular Spark training job using the TensorFlow. So when you submit that, the Spark now supports the Horwood distributed training library. And at the time when you submit that particular job, you're going to say, use my GPU for the entire application, right? Because your training is going to happen on GPUs, use the GPUs for do that. But you can only do that when you launch your Spark application. You won't be able to tell that this particular task for training should use GPUs and this particular task should use CPU. You can't do that. It's all or none right now. But down the road, as we figure out the problems, how we can actually have more granular scheduling abilities to say this particular task can request to use GPU if it's available.
you are on mute, Jules.
Yeah, we do install PyArrow for you, right? So when you download something, and you're using PySpark, the PyArrow version 2.11, I believe, is installed for you already. So you need PyArrow to use Pandas.
And to all of our participants, if you want to take the microphone and ask directly to Jules anything you want to ask him, please feel free. That's the purpose of this panel. You also have the microphone for you. So I have a question for you, Jules. Now that you talk about the Zen project, I think that's a huge deal for the Python users, and this is also big questions for all of us. We are always asking this in all of the events. This is a repetitive question, and maybe you may suppose what I'm about to ask you. And now that we have quite good improvements in Python, do you think there is still like a difference between using Scala and Java versus PySpark? This is something that is always concerning the developers. Now they want to get the most of the framework, so we want to use the theory says, well, if Scala is written in Scala, if Spark is written in Scala, you want to use that language because that will give you more control. But I don't know with 3.0 if that's important. Or
those are very good questions, and there are two answers to it, right? And the answer is actually evolutionary, right? when 1.x was actually released, the PySpark was always a second-class citizen, right? It followed along in terms of the APIs and all that, because the reference architecture was in Scala and everything was written in Scala. So even the documentation somehow lagged behind in certain codes that existed in Scala, but did not exist in PySpark. And also there was also the perceptions that if I'm using PySpark, remember the PySpark runs as a Python process, and we actually create a socket where when you run a particular Python UDF or a Python function, we're going to create a Python process, and we're going to pass it to that to execute that and bring it back, right? So that was the original thing, and that's why people thought that PySpark was slower. And so if you're executing Lambda functions that we can't optimize, that we can't look into, that we can't look at the code, the least thing I could do is I'm going to pickle that Lambda function. I'm going to use PySocket to send it to the process and execute it. The executor will execute the Lambda function and return me the results. Right? That was the old world. In 2.x, when we unify the APIs, right? When we say if you're going to use data frames and data set in SQL, it doesn't matter. If you use the built-in functions of Python or PySpark that Scala uses, the PySpark uses, the underlying code is going to be exactly the same, right? But if you're going to use some Lambda function that the optimizer can't look into it because it doesn't know what you're doing, it's opaque to it, then you're going to have the performance over there. So if you do a lot of Lambdas in PySpark that are not part of the built-in functions, then you'll hit the performance hit. But if you use all the built-in functions, all the group by, all the map and everything, then the underlying code is going to be, the Python code is going to be converted to Scala. So you're actually using the same JVM, right? You're not creating an extra process. So the answer to the question is that stick to the built-in APIs that PySpark tells you to use, which are at par now, almost today. There might be one or two functions, but today is at par with Scala. So when we release a particular version of a release of APIs, you'll have the PySpark, you'll have Scala, and probably to some extent R as well.
All right. Now,
Right.
giving it the question a little like another perception is, what is your preferred language when it comes to use Apache Spark, and why? Why did you like it?
Well, I mean, see this.
All right, there you go. Silly question.
I worked at Sun Microsystems, and I was part of the Java group as well, and so this was why I had this particular poster. So obviously, I very much favored the JVM, and then Scala. I mean, in a way, is a functional programming language and also a procedural language, and it's a big shift for people who are coming from Java and moving to Scala. So for me, the transition was a lot easier to go from Java to Scala, although for the first 6 months, you'll start to think in terms of how do I do that in Java? But there are better ways to do it in Scala because this whole notion of functional programming. So in terms of preference, I think today, if you took a survey of what is the most popular language being used today in big data, in machine learning, what do you think the answer is?
I'll say Python, I think.
There you go. There you go. So you got your answer, right? You got the answer. And so all the frameworks do that. The popular frameworks have a Python interface, right? Because all the data scientists and all the developers are using Python, right? PyTorch. It started with Torch, C++, Julia, all that. Everybody's using Python. So I think the choice is up to you, right? So you're not being penalized if you use PySpark to do ETL. Right? You can use Scala or you can use Python. Whatever language you feel comfortable, you can actually write that. My only caveat is that if you stick to the built-in API functions, which are common both in data frames and data sets for Python as well as Scala, then it's a moot point. It's a moot point. I'm here. I don't. It's only 6 o'clock for me. It's 8 o'clock for you guys.
Awesome.
Mm-hmm. Yes, 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 yes. Hmm. How do you, how, mhm, 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 mhm. Absolutely, absolutely, absolutely. Mhm, 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 mhm. So here is my suggestion. We have a great advocate in the Apache Spark community who actually runs these Twitch marathon. Her name is Holden Corral. Do you know about Holden Corral? If you Google Holden Corral, you'll say. So she used to run how to file a PR, how to file a PR for Spark, right? And if you're starting initially, you get a bit intimidated, right? Because how do you actually file a PR, right? I would start by taking small things. I would start with documentation, right? Go to PySpark documentation, go to Scala documentation, go to Java documentation or Scala documentation, and look at the documentation. And if you see something wrong, or if you don't understand something, or if you think this particular API could actually use a code snippet, file a PR, right? That's a good way to start contributing, right? So you start with documentation because documentation will force you to do two things. It will force you to understand the behavior of the Spark API. It will force you to say, okay, I'm doing apply in Pandas and the description tells me this thing, but when I used it, the behavior was something else. So what's wrong with it, right? So you would go straight to the source, spark.org.do, do a clone of that, go to the code itself, and figure out what is it about that's actually missing. Learn the code, it will force you to say, oh, now I understand exactly what that particular piece of code is doing. So I'm going to file a PR request to say the documentation shouldn't say this. It should say this because according to the code, this is what it's actually doing. So that's actually a great way to get started because you get the confidence to do that. And we in the community encourage people to start filing the documentation. And here is a great way for the Bogota Spark community to get started because I can see that you guys love PySpark. So get involved with Project Zen. Project Zen is a community effort to improve, right? To improve. So go through the documentation and remember, there's a lot of documentation in PySpark that needs to be converted from the old documentation to using Python 3.hints, right? That documentation has to be changed, right? And so it will be great for anybody to file PR requests. Okay, I'm going to take SQL functions and I'm going to change all of them to include the signature for the Python hints. So that's a great way to start that. So if you are new to contribution, that's the way to start. Once you build the confidence, once you see your PR being reviewed, your PR being accepted, people will know who you are. Oh, Juan actually did that. Or this Jose actually filed a PR request. And now he's taking to the next step where he's actually fixing a bug or he's adding a feature. And I'm going to file a PR request. So the committers out there welcome these kinds of additions from the community. That's the whole particular reason, right? Yeah, Holden Corral. Yeah, there you go. Holden Corral. Yeah. And she used to conduct these monthly PR reviews where she actually said, how can I get the committee involved in doing that? And she would be actually a great speaker to come and talk at there. If you yeah,
Awesome.
if you send an email, I can tell that I spoke at the Bogota Spark. They really want to have you come, and she can talk about how to contribute as well, right? So she can give you hints about that.
That will be a very interesting.
All right. So what I'll do, so Juan and Jose, just remind me, send me an email, and your name says Apache Spark. The guy with the glasses asked me the question. What's your name? Miguel. Okay, Miguel. Yeah, Miguel. What I'll do is I'll send an email to Holden and say, hey, listen, if you're free, these guys would love you to share about how you can actually be a Spark contributor, right? And she's a great advocate. She's a good friend of mine. I love her. And yeah, so I'll do that.
Thank you so much, Jules. Much appreciated.
Do I have to give you guys a quiz now to get the book?
Right.
Yeah.
Well, one last question before getting into the content. Well, with 3.0, we got a lot of features that are quite positive and useful for traditional BI load. So we have dynamic partition pruning, we have ACID transactions with Delta Lake. So I think we are in a pretty good shape to contemplate Spark as a good option for traditional BI workloads. So we want to have star schemas, we want to have ETLs and that kind of stuff. So I'm wondering, what do you think is that missing component that we need to put on top of Spark to make those worlds totally compatible? You know, like they can work naturally.
Yes. Well, I mean, this is if you look at my slides, I gave you the progression of data lakes to the lake houses, right? So if you look at the evolution of warehouses, if you look at the first generation of warehouses, those were, you created data marts, right? You created this massive warehouse where you store all your structured data, right? It had to be structured, and then you use proprietary software, paid them millions of dollars, Teradata and all these other guys to do that. Then there was this notion of, okay, you don't need to have your data structured. You can just dump your data in this thing called data lake, right? So that was the evolution from structured data and data warehouses to open source Hadoop, data lakes, a read-on schema, not write-on schema. Star schema in warehouses were write-on schema. Data lakes were read-on schema. I'm just going to put shit on it. I don't care what it is. When I try to read it, I'll figure out what my schema is going to be, and I only read the stuff that I need that. The problem I told you about massive data lakes is the 10 problems I told you about. Because if you wanted to do today's analytics that do BI and SQL analytics, that do machine learning with structured data and also unstructured data, and that allow you to generate BI reports, you need a combination of what we call the lake house, right? And the lake house is a combination of having structured data underneath your lake house, and then you have these vertical applications that can actually work on it, right? So whether it's BI, whether it's Tableau, whether it's Click, you name Informatica, they can actually connect using straight into the lake house. Right, and then you have an underlying fast engine that actually gives you everything you need. And Data Lake and Spark is the hub. Think of it this way, right? When Edison created electricity, right? When Edison created electricity, his client asked him, "How are you going to make money, Edison?" He goes, "Think of electricity as a utility, right? The way you're going to make money is not out of selling the utility." Right? Because you don't make the money, the utility will be there. If you turn on the switch, the electricity is going to flow. The people who are going to make money are the people who are going to build appliances on top of the electricity. Right? So in other words, when you start using the utility, you plug in whatever appliance you have, depending on whether you're in Latin America or within Europe, you're going to get either 110 AC/DC or you're going to get 240, but that is guaranteed. That's your utility. You're always guaranteed to get that. But the people who are going to make money are the innovations who are going to build appliances. So now people started building lamps, people started building refrigerators, people started building toasters, started building all kinds of appliances. And the appliances uses the utility which is built on top of that. And that was Edison's vision. So I would say that Spark and the underlying data lake and data house are going to be utilities. People are going to make money who are going to build things on top of that. Right, so whether you have machine learning applications, whether you have BI analytics, where you have whatever you actually need to consume that structured data or unstructured data or reliable data, and that is your utility. You turn on that particular cloud, and that thing is going to be there. But the thing that's going to sit on top of that is the one that's going to make money. Does it make sense? Does it make sense?
Awesome. Yes, makes total sense. Thanks, Jules.
Sounds great.
I'm not changing the world. The entire community is changing the world. You guys are changing.
Yeah. You're part of a community. But Miguel, wondering if we have like any additional questions before closing the panel from the audience. So I'm not sure. Yes, just before moving forward.
Yeah. No, I think that we feel the same excited. Like we have very excited with your talk, and thank you very much.
You're welcome. So now I have to answer you guys a question, right? I have to ask everything. All right.
Yes,
All right.
please.
Now here's a trivia question on football. I'm a big football aficionado, and obviously my big team is Brazil. Colombia was a favorite team, but my favorite player in the history of Latin American football was Carlos Valderrama.
Awesome.
Right? Now, when Carlos Valderrama was signed up by Montpellier in France, what was his jersey number that he was wearing, both for Montpellier when he signed up and when he played for the national team, and what position was he playing? So that's my question to the community, and whoever answers it first, three answers. What was the jersey number? What position he played, both for Montpellier and for the Colombia national team, and what position he played?
That's the contest.
You can't Google it. You can't Google it. No. Disable Google. You have to be 5 seconds. You should be able to answer the question. Whoever answers the question, you give them the book.
That's a hard
one. I think that we in Twitter.
El Pepe. Yeah. So what was his jersey number? What position he played, both for Montpellier and for the Colombia national team?
So, folks, go and hit our Twitter account, Bogota Spark. You already heard Jules. There are his three questions. If you answer that right away, you are the winner of one of the books that he helped write. Right?
Mm-hmm.
Right. Awesome.
Cool.
All right.
Are we waiting for the answers, or?
I'm gonna examine that offline. I think we can.
Okay.
Twitter is capturing the date times for us.
Okay. All right. Gracias. Thank you very much. Buenos dias.
So much, Jules.
And thank you for inviting me. And Jose, I'm going to send you the LinkedIn PDF for the slides so you can actually share it with the community. Okay.
Sure. Thank you. Thank you, Jules.
All right.
Okay.
All right. Cheers. Adios.
Thank you. Bye.
Awesome. Thanks.
Bye. Bye, community.
Bye.